In combat, riflemen take full advantage of natural concealment to prevent an enemy from observing their movements. By proper use of natural cover and concealment, the enemy may be deceived as to the position occupied by riflemen. By taking advantage of the cover afforded by the ground, riflemen gain the maximum protection from hostile fire without digging in. When an attack has been stopped by hostile resistance, riflemen may be ordered to dig in and hold the ground gained. A rifleman sights his skirmisher's trench so that he can place effective fire on that part of the enemy line he is expected to cover. Squad leaders check to see that members of their squads sight their skirmishers' trenches so that they have effective fields of fire, and designate men to keep up the fire while other members of the squad dig in. Next in importance is the protection of the individual soldier against hostile fire. Since the work must be done under rifle and machine gun fire, a skirmisher's trench is constructed. The skirmisher's trench is dug with the entrenching tools carried on the infantry pack and with the soldier lying in the prone position. Some fire must be continued, and as the entrenching tools do not suffice for all members of the squad, the corporal designates certain men to continue fire while the others dig. In using the infantry pick mattock, it is necessary to lie on one side and to spread the legs in scissor fashion with the upper leg forward and stiff to secure leverage. With the lower hand, grasp the pick handle at the point about halfway between its end and the head. With the other hand, grasp the handle near the end. Loosen the soil to the front and side with short vertical strokes. To use the infantry shovel, lie on one side and spread the legs apart in scissor fashion with the lower leg forward and stiff to secure leverage. With the lower hand, grip the shovel handle near the blade, and with the other hand, grasp the handle from above at the T. Excavate by pushing the shovel forward and deposit the soil above the head or to the far side of the excavation. To change position, roll into the excavation and work in a similar manner from the other side. In soft ground, the soldier can mask himself from the front and secure fairly good protection from small arms fire in from 10 to 15 minutes. A skirmisher's trench about 9 inches deep with a parapet 9 inches high should be completed in about 1 hour. It gives excellent protection against rifle and machine gun fire, and to some extent against high explosive shells. It is too shallow to protect a soldier satisfactorily from shrapnel fire. In the organization of a defensive position, several hours are usually available to riflemen in which to construct hasty field fortifications. Since they are not under rifle and machine gun fire, the work proceeds in a more deliberate manner. In a situation of this kind, the engineer regiment would deliver infantry tool trucks near the position. Initially, 1 tool truck per frontline infantry battalion is usually available. Tools are distributed on the basis of requirements to the various organizations. One infantry tool truck carries 250 shovels, 125 picks, 26 saws, 26 axes, sandbags, chicken wire, and a kit of small tools. A combat group is an area usually occupied by a rifle platoon or a section. The section leader has been ordered by his platoon leader to organize a combat group. Before the section can construct hasty field fortifications, consideration must first be given to the location of weapons so that foxholes are properly sighted in order that riflemen can carry out their fire missions. This having been determined, full advantage is taken of all existing obstacles and of all natural cover afforded by the ground. Men sent to draw the engineer tools deliver them to the sections at the positions. Having sighted the weapons, the section must now do the necessary clearing to improve the fields of fire. In clearing fields of fire, care must be taken that camouflage assets are not destroyed. Low-hanging limbs on large trees may be cut off, and underbrush thinned out, thus increasing the defender's field of observation and fire, and yet not materially decreasing the defender's concealment of their own position. The fields of fire should be cleared to a depth of at least 100 yards. Anything like straight lines marking the limits of the clearing must be avoided because they disclose the position. Weapons have been sighted and fields of fire improved by clearing. Next, foxholes are constructed to protect weapons and personnel against hostile fire. In breaking the ground, sod or clumps of grass are laid aside to be used later in camouflaging foxholes. A foxhole is a roughly circular pit with an average diameter of 3 feet. The sides of the pit may be sloped to prevent it caving in. The smallest type is the sitting foxhole. It is about 1 1/2 feet deep, with a parapet 9 inches high in front of it. Such a pit protects a man in the sitting position. All work is camouflaged to blend into the surrounding. In medium soil, using engineer tools, a soldier should complete the sitting type foxhole in about 30 minutes during daylight. If infantry entrenching tools are used, it should be completed in about 45 minutes. A deeper foxhole is the kneeling type. It is about 2 1/2 feet deep with a 1-foot parapet in front of it. It can be completed in medium soil during daylight by one man using engineer tools in about 45 minutes, or by one man using infantry entrenching tools in about 1 hour and 10 minutes. The kneeling type foxhole shelters a man firing from the kneeling position. The largest foxhole is the standing type. It is about 3 feet deep and has a parapet 18 inches high. This foxhole can be completed in medium soil during daylight by one man using engineer tools in about 1 hour, or by one man using infantry entrenching tools in about 1½ hours. After the new work is completed, it is camouflaged. The standing type of foxhole provides cover for a rifleman or automatic rifleman firing from a standing position. To provide for communications between foxholes, shallow connecting trenches are dug. This type may be taken as an average. It has an average width of 2 feet and a depth of 1½ feet. The sides of the trench may be sloped to prevent it caving in. The parapet is 9 inches high. 5 yards of trench between foxholes can be dug with engineer tools in about 1 hour and 20 minutes by one man under ordinary conditions. Looking at a part of the combat group, we find the men well protected from hostile fire by standing type foxholes. Foxholes are the best cover that can be constructed in a short time to protect riflemen from hostile fire. Because of the small exposed area and the deep sides, the foxhole provides excellent protection against tanks. A small ditch is dug around the foxhole to drain off the water so that it will not flow into the hole. Riflemen and automatic riflemen have good fields of fire improved by clearing. The shallow type connecting trench furnishes protection for a man crawling on his hands and knees. Looking at the combat group from the direction the enemy will advance, the position is well concealed. Just 15 yards to the front, a rifleman is located, yet he cannot be seen. Let us move a little closer to this foxhole. The camouflage material has been so carefully placed that the enemy will find it difficult to locate the position. Yet this rifleman has a good field of fire to the front. Barbed wire entanglements are very effective obstacles to the advance of an enemy. Barbed wire and pickets are brought up as close as practicable to the site of wire entanglements by engineer trucks. They are then turned over to the infantry for erection. At this point, bobbins of wire are made from reels. The wire and pickets are then carried to the wiring parties by carrying parties. A carrying party of 16 men is required to carry material for a 50-yard belt of double apron fence. They can keep the wiring party supplied from a distance of about 800 yards. For longer and shorter carries, the party can be increased or decreased in proportion to the distance. Wiring parties are detailed from infantry units. This party is preparing to construct tactical wire, a double apron fence across the front of the position. A wiring party consists of a non-commissioned officer and 9 men. The party is divided into 4 teams. One team has 3 men, and 3 teams have 2 men each. The non-commissioned officer carries out 1 bundle of long pickets, paces off the 6-pace interval between pickets along the center line, and indicates where the pickets are to be set. He then supervises the construction of the double apron fence. Each member of the 3-man team carries out 1 bundle of long pickets and lays them out along the center line. This team then screws the center line pickets into the ground. Each member of the 2-man team carries out 1 bundle of anchor pickets. One team lays out and screws in the front anchor pickets, while the other team lays out and screws in the rear anchor pickets. The anchor pickets to which the diagonal wires are fastened are set 3 paces from the center line and midway in the interval of center line pickets. The other 2-man team distributes bobbins of barbed wire along the fence at points where they will be needed. As a team completes one task, it begins another task. The work is so proportioned that a team will complete a task just ahead of the team following them, so that they do not interfere with each other. The eyes of all pickets are set parallel to the length of the entanglement. After the center line pickets are set, the 3-man team runs out the diagonal wire on the front apron. One man walks out with the bobbin, unwinding as he goes. One man fastens the wire to the front anchor pickets, and the 3rd member of the team fastens the wire to the long pickets. The wire is firmly fixed in the eye of the picket so that it cannot slip up or down. In case one bay is cut, the wire in the other bays cannot slip through the eye. After the 2-man team completes laying out and screwing in the front anchor pickets, it works on the tripwire of the front apron. Tripwires are the lowest horizontal wires of the front and rear apron. One man runs out the wire, and the other man windlasses the tripwire to the diagonal wire. Windlassing consists of twisting the 2 wires together with a rack stick. When the 2-man team completes laying out and screwing in the rear anchor pickets, it runs out and windlasses the 2nd horizontal wire to the diagonal wire of the front apron. The men work from front to rear. By following this sequence, they never have to step over a strand of wire. The 2-man team that distributed the bobbins of barbed wire runs out and windlasses the top horizontal wire to the diagonal wire of the front apron. The method of windlassing horizontal wires and diagonal wires where they cross prevents the wire from sagging in adjoining bays if the wire in one bay is cut. Barbed wire is strung loosely to increase the entanglement effect. As the teams complete their tasks on the front apron, they next run out and fasten the wires on the fence. The 3-man team works on the bottom horizontal fence wire. One man runs out the wire, and the other 2 men of the team, working on alternate pickets, fasten the wire to the pickets. The 3 2-man teams, working in the same order as on the horizontal wires of the front apron, work on the 2nd, 3rd, and top horizontal wires of the fence. One member of each 2-man team runs out the wire, and the other member fastens it to the pickets. One bobbin of wire is sufficient for approximately 1/2 of one strand of wire for a 50-yard belt of fence. It is necessary to splice on a second bobbin at the point where the first bobbin is used up. The splice is made by twisting the two wires about each other with the hand. After the three-man team completes the work on the bottom fence wire, they work on the diagonal wire of the rear apron. One man runs out the wire, one man fastens the wire to the long pickets, and the third member of the team fastens the wire to the anchor pickets. The two-man team that worked on the second horizontal wire on the fence works on the top horizontal wire of the rear apron. The two-man team that worked on the third horizontal wire on the fence works on the second horizontal wire of the rear apron. The two-man team that worked on the top fence wire works on the trip wire of the rear apron. In each of these three two-man teams, one man runs out a horizontal wire of the rear apron, and the other member of the team windlasses the wire to the diagonal wire where they cross. Diagonal and horizontal apron wires begin and finish on the end anchor pickets. Horizontal wires on the fence begin and finish on the end centerline pickets. They are not carried down to the end anchor pickets. Wire should be strung loosely because taut wire is more readily cut by wire cutters and shell fire. Note that the wires are windlassed wherever they cross, and that the belt of wire is not conspicuous at a distance, but blends into the surrounding grass and shrubs. Gaps in the tactical wire should be closed in when not in use by means of portable obstacles. Rebarred wire has been used to close this gap. The barbed wire concertina is an effective type of portable obstacle for closing gaps in double apron fence. Barbed wire concertinas, like rebarred elements, are prepared in advance by the engineers, and in the field need only to be opened out, supported on a wire strung between posts and stapled to the ground. The gooseberry has been used to close this gap. It consists of barbed wire balls connected by spirals of the same material. It is used principally to block trenches, but may be used to make emergency repairs to existing obstacles. Tactical wire obstacles placed in front of the position will delay assaulting enemy troops reaching the position and so cause congestion, which holds them under effective rifle, automatic rifle, and machine gun fire for a longer time. Wiring parties from the infantry construct 4-strand protective wire fences around the forward and rear combat groups. 4-strand fence, which is the fence element of the double apron fence, is often used initially for protective wire due to its speed of erection and relatively small amount of material required. When time permits, it may be converted into double apron fence. In combat, the members of the caliber 30 machine gun sections take full advantage of natural concealment to prevent an enemy from observing their movements. By making proper use of cover and concealment, the enemy may be deceived as to the location of the machine gun positions, and members of the section gain maximum protection without digging in. When an attack has been stopped by hostile resistance, machine gun sections may be ordered to dig in and assume the defensive. Caliber 30 machine guns are sighted so as to perform the missions assigned to them. Section leaders check to see that guns of their sections are properly sighted. The next work is to protect weapons and members of the section from hostile fire. Digging with the entrenching tools and keeping low, the men at the guns gradually dig into the ground to gain further protection from hostile fire for themselves and for their weapons. During the progress of this work, they may be called upon to fire on targets appearing in their sectors of fire. They take advantage of every opportunity to continue digging until a shallow type emplacement is completed. Members of the squad not needed at the gun position construct skirmishers' trenches. This work is done with the entrenching tools carried on the infantry pack and with men lying in the prone position. The open, shallow type emplacement for the caliber 30 machine gun is 6 feet wide and 8 feet long. The sides of the excavation may be sloped to prevent caving in. The depth is about 18 inches. It will vary due to the slope of the ground. With 2 men working with individual entrenching tools under fire, this type emplacement can be finished during daylight in about 3 hours. In the organization of a defensive position, caliber 30 machine gun sections usually have several hours in which to construct hasty field fortifications. Since they are not under rifle and machine gun fire, the work is carried on in a more deliberate manner. Machine gun section leaders point out the gun positions to the squad leaders and designate the sector of fire and the final protective line assigned to the section. Squads are brought forward and members assigned tasks. The gunner and assistant gunner of each squad are used initially for digging the emplacement so that they are immediately available at the gun in case of an emergency. The open, standing type of emplacement is being constructed. Engineer tools normally would be used for this work. When clearing is necessary, 2 members of each squad are usually assigned to the task of clearing essential fields of fire for the section. The clearing is limited to cutting bushes and low limbs of trees. The trees themselves are left standing, as they interfere with a field of fire less in this position than if cut down. The clearing must not disclose the position. Anything like straight lines marking the limits of the clearing must be avoided. The remaining members of the squad dig standing type foxholes in the vicinity of the emplacement. Only 2 men can work to advantage in the open standing type emplacement at one time. Soil excavated must be carried away or spread and covered with topsoil. The standing type foxholes for the protection of members of the squad not needed at the gun have been completed. They are the same type as dug by riflemen. The open standing type emplacement for the caliber 30 machine gun is 6 feet wide and 8 feet long. The sides of the excavation may be sloped to prevent caving in. the forward part of the emplacement, which is the gun platform, is 16 inches deep. The slope of the ground will cause this depth to vary somewhat. The rear portion of the emplacement is 4 feet 4 inches deep. Usually the standing type emplacement is developed by deepening the rear portion of the shallow type emplacement. In loose soil, it is often necessary to revet the rear portion of the gun platform to keep it from caving in. Stakes and small branches cut when clearing the fields of fire may be used for this purpose. Open type emplacements permit all-around fire and can easily be adapted from shell holes. A small trench is dug around the emplacement to drain off surface water. Water that falls in the emplacement must be bailed out. Over at the other squad of the section, the excavation of the soil has been completed and the men are well along in their task of camouflaging. The sod and clumps of grass were carefully removed when the ground was broken and now find good use. The open, standing type emplacement requires little material and is easily concealed from aerial and ground observation. 2 men digging in medium soil with engineer tools can complete the open standing type emplacement for caliber 30 machine guns in about 4½ hours. Looking at the emplacement from the direction of the enemy, you are unable to see it, although it is only 15 yards to your front. Moving up to the position, we find that the camouflage material has been so well selected and placed that it matches the nearby vegetation. The action of the caliber 50 machine gun squads in combat, except for positions and fire missions, is much the same as that of the caliber 30 machine gun squads. Caliber 50 machine guns are located and sighted to fire in the direction of likely avenues of approach of enemy tanks. Digging with entrenching tools under hostile fire, the gun crew gains further protection for itself and its weapons. If tanks appear in their sector of fire, they temporarily abandon the work and fire on the tanks. Members of the squad not needed at the gun construct skirmishers' trenches. The work is done with the entrenching tools carried on the infantry pack and with the men lying in the prone position. The open, shallow type emplacement for caliber 50 machine guns is 6 feet wide in the forward portion and 7 feet wide in the rear portion. To prevent caving in, the sides may be sloped. It is 10 feet long and about 16 inches deep. The depth will vary due to the slope of the ground. With 2 men working in medium soil, using individual infantry entrenching tools, this emplacement can be completed in about 3 hours. In defensive situations where the enemy cannot reach the position for several hours, the work proceeds in a more deliberate manner. Engineer tools would normally be available for that work. The squad leader places the gun at the position indicated by the platoon leader and assigns tasks to the members of his squad. The gunner and the assistant gunner are used initially for digging the emplacement, so that they are instantly available at the gun in case of emergency. The open, standing type of emplacement is being constructed. When clearing is necessary, 2 members of the squad are usually assigned to the task of clearing the essential fields of fire. The clearing is limited to cutting bushes and low limbs of trees. The clearing must not disclose the position. Anything like straight lines marking the limits of the clearing must be avoided. The remaining members of the squad dig standing type foxholes. Only 2 men can work to advantage in the open, standing type emplacement at one time. Soil excavated must be carried away or spread and covered with topsoil. The standing type foxholes for the men not needed at the gun have been completed. They protect the members of the squad when they are not needed at the gun and are the same type as those constructed by riflemen. The open standing type emplacement for the caliber .50 machine gun is 6 feet wide at the forward portion and 7 feet wide in the rear portion and is 10 feet long. The sides of the excavation may be sloped to prevent caving in. The forward part of the emplacement, which is the gun platform, is 16 inches deep. The slope of the ground may cause this depth to vary. The rear portion is 4 feet 4 inches deep. Usually the standing type emplacement is developed by deepening the rear portion of the shallow type emplacement. Open type emplacements permit all-around fire and can easily be adapted from shell holes. A small trench is dug around the emplacement to draw off the surface water. Water in the emplacement must be bailed out. The new work is camouflaged. The sod and clumps of grass removed when the ground was broken are used to good advantage in this work. The open, standing type emplacement requires little material and is easily concealed from aerial and ground observation. The emplacement for the caliber .50 machine gun is of the same type but somewhat larger than that of the caliber .30 machine gun. It can be completed by 2 men digging in medium soil with engineer tools in about 5½ hours. You are unable to see the emplacement from a distance of 15 yards out in front. Moving up to the position, we find that the camouflage material has been skillfully arranged to match the surrounding vegetation. In combat, the mortar relies mainly upon defilated positions for its protection. In sighting the mortar, a stake is driven into the ground to designate the mortar position. Two aiming stakes are then driven in the ground to mark the direction of fire. A suitable observation point is necessary to carry out the assigned mission. The positions are improved as much as time will allow by digging in the base plate and by camouflage. The camouflage usually consists of a camouflage screen constructed over the mortar to conceal it from aerial observation. The mortar is screened from ground observation by the high ground to the front. If the situation demands, members of the mortar squad not on duty at the mortar construct foxholes for further protection from hostile fire. The mortar, because of its high trajectory, can cover areas which cannot be reached by the fire of rifles and machine guns due to their flat trajectories. The work at the mortar position can be completed in less than 2 hours. Platoon command posts are located within the combat group occupied by a rifle platoon. Usually the same type of hasty fortification constructed by the riflemen is constructed by members of platoon headquarters to protect them from hostile fire. Company command posts are located in the rear part of the company area. If a defilated position is available which protects the personnel of the company headquarters from hostile fire, it is only necessary to conceal the command post from enemy observation. Other situations may require the construction of foxholes to protect the personnel against hostile fire. The new work is camouflaged to prevent the enemy from discovering the location of the command post. Battalion command posts are usually located in defilated positions which protect the personnel from hostile fire. Advantage is taken of woods to provide concealment from enemy observation. Such a location requires but little camouflage to conceal the installations from enemy aerial or ground observation. Other situations may require the construction of foxholes or larger pits to protect the personnel from hostile fire and observation. The new work is camouflaged. The work at the battalion command post is done by the headquarters personnel and normally progresses at a rate of speed that assures the completion of the work by the time the front-line troops have completed their hasty field fortifications. To prevent newly beaten trails from disclosing the location of the command post to enemy aerial observers, messengers entering or leaving the command post do not follow the same route. In some situations, the battalion observation post may be located in a well-protected position at a high point in the forward part of the battalion sector. From this position, the personnel from battalion headquarters can see the battalion sector and observe enemy activity. Other situations may require considerable construction to protect the personnel at the battalion observation post. In such a case, a pit is usually constructed and camouflaged. Enemy information is transmitted to the battalion command post by telephone. The battalion aid station is located in the rear part of the battalion area. A location near water is very desirable. It is near covered and protected routes over which litter bearers can carry seriously wounded personnel. Less serious cases instinctively follow such routes, which are known as lines of drift. Shelters are constructed to protect the equipment and the wounded men who are brought to the aid station for treatment. Motor vehicles of a battalion usually bivouac in the rear area behind the regimental reserve line. Advantage is taken of concealment afforded by trees. This truck has been placed on the proper side of the tree to take advantage of the shadow cast by the tree. In placing saplings or boughs around the truck, they should be placed vertically with the butt end down as they grow and not horizontally. It will be difficult for an enemy airplane observer to pick up this well-concealed truck. You have seen the various types of infantry hasty field fortifications in various stages of construction. When infantry troops occupy a defensive area, field fortifications are never complete, but work goes on as long as the area is occupied.